Welcome back to Kamal Kunj Home Academy. Encounter with the art and science of ceramics. In this session, we will discuss about the manufacturing process of Fireclay and high alumina refractory bricks. Now suppose customer has given the following specifications of Fireclay and high alumina refractory bricks. Here for Fireclay they are the specification alumina 40%, for in case of high alumina 62%. They are different. Fe2O3 maximum 2.5%, 1.2%. Bulk density, in short it is written as BD, gram per cubic centimeter, 2.0, 2.55. Apparent porosity, in short it is written as AP, percent maximum 25/16. Cold crushing strength, short it is written as CCS, kg per centimeter square, minimum 200 and here 600. Pyrometric cone equivalent. Pyrometric cone equivalent, short it is PC value. Using autumn cone, 30 to 37. Refractness under load, in short it is RUL. TA value should be minimum 1400 and 1500. Permanent linear change, in short it is written as PLC, percent maximum, plus minus 1% and plus minus 0.3%, and this is size tolerance. Now the first step for the manufacture of these bricks would be the selection of raw materials. So first step is selection of raw materials. Raw materials. Now in case of Fireclay bricks, you need calcined non-plastic Fireclay and plastic Fireclay. So in case of first one, for Fireclay bricks, for Fireclay bricks, we need calcined non-plastic Fireclay, calcined non-plastic Fireclay, and plastic Fireclay, plastic Fireclay. Now calcined clay and contains about 35 to 36% Al2O3 and plastic Fireclay around 30-31% alumina Al2O3. So here alumina required is 40%. So some amount of high alumina bearing material is also needed. So let us take calcined bauxite, and raw kyanite. And for high alumina bricks, need high alumina bearing raw materials. For second, high alumina bearing materials are needed. Calcined kyanite, calcined bauxite, and brown fused alumina, some technical alumina, and plastic clay, plastic fire clay. We also need silimanite, now these are the raw materials for fire clay bricks: calcined, non-plastic fire clay, plastic fire clay. And to add some alumina, increase the alumina percentage to 40%, you need some high alumina bearing materials, for example calcined bauxite or raw kyanite. This is the selection of raw materials. Next step will be chemical analysis of raw materials. Next step will be chemical analysis of raw materials. Raw materials. Test for determination of A2O3 Fe2O3 and CaO. For estimation of quantity of raw materials required, you need chemical analysis of raw materials. So you have to determine alumina percentage, Fe2O3 and CaO. Though it is not mentioned in the specification, CaO content, lime content, but it is very crucial to know the amount of content of lime in the raw material. Why? Because lime in presence of Fe2O3 forms low melting compound, that is calcium ferrite, calcium diferrite and dicalcium ferrite. They are low melting compounds. Lime in presence of Fe2O3 iron oxide forms low melting compounds. It melts in the region 1100 to 1250 degrees Celsius. So it will affect the PC value, pyrometric cone equivalent, and refractness under load. Hot load bearing capacity will be reduced. So lime content should be as minimum as possible. It should be less than 0.5%. The raw material lime content should be as minimum as possible. It should be reduced below 0.5%. 0.2 to 0.3% is sufficient. Should not be more than that, because it will affect the PC value, mainly PC value and refractness under load. If we reduce both, so it is necessary so lime content in the raw material is undesirable. Lime content in the raw material is completely undesirable. This quantity is undesirable in the raw material. Now the chemical analysis for our next step would be estimation of raw materials. Raw materials needed. For estimation of raw materials, the chemical analysis is needed. And the next step would be, after estimation of raw materials for the production of Fireclay and Alumina bricks, you make sample in the laboratory. Sample preparation and testing in lab. You make 2 to 3 compositions for both the specification and find the best and economical composition for both. Find best and economical composition. And with that composition, we go for production on plant scale. First, you develop the material in the lab, develop the composition for both, and then go for the best composition or also economical composition for these bricks. Now, how to estimate the raw materials? Estimation of raw materials. After knowing the chemical analysis of different raw materials, you can estimate, find out the quantity required for making Fireclay and Alumina bricks. Suppose first we have to estimate the raw materials required for making Fireclay bricks. So we will take calcined non-plastic Fireclay, calcined non-plastic Fireclay, In Fireclay, alumina percentage is around 34 to 36%, but you need 40% alumina in the composition. So some high alumina bearing materials is to be added. So let us take calcined bauxite. And then you may also take raw kyanite, or may not take. Let us take two compositions. And plastic fireclay. Now suppose non-plastic calcined clay is 50%, calcined bauxite 25%, raw kyanite, you leave this in first composition, and 25 plastic fireclay. Make two compositions. Calcined clay same 50%, bauxite reduce 20%, add kyanite 5%, and plastic clay same 25%. Now if you calculate, if alumina is around 35%, so 50% will be 35 multiplied by 17.5%. So L23 comes out to be, from calcined clay, L23 is 17.5. From calcined bauxite, in calcined bauxite alumina is generally 80%. So here 25 will become 20. And plastic clay alumina is around 30%. So it becomes 7.5. So alumina becomes 45%. So in first composition, alumina is coming 45%. We need minimum 40%. So it is okay. Next is 17.5. Here 20% become 16. If we take 80% alumina, and kyanite 2.5, raw kyanite 2.5, 5%, 50% alumina, and plastic fireclay same. It comes out to it 43%, 43.5. This is also okay. You need minimum 40%. It is coming more than that. So you can try these two compositions. Similarly, you can calculate for high alumina bricks the raw materials required. Now let us make process flowchart for making these bricks. This is estimation of raw materials for Fireclay refractory bricks. Similarly, you can calculate for raw materials required for high alumina bricks. Now let us go for flowchart of the different processes. You need calcined non-plastic fireclay. So calcination or non-plastic fireclay is needed. So flow chart for making refractive bricks. For Fireclay, you need calcination of non-plastic Fireclay. On plastic Fireclay. Calcination is done generally either in a smaller scale DD kiln or shaft kiln or rotary kiln. Calcination is done in either DD kiln means downdraft kiln, or shaft kiln, or rotary kiln. So after calcination, we needed crushing and grinding. Crushing and grinding of calcined clay. Is the next step. Different primary crushing for large lumps, jaw crushers are used. Then impact mill or pan mill, different grinding machine equipments are used for crushing and grinding. That is jaw crusher, impact mill, or pan mill. Used for crushing and grinding of calcined clay. And ball mills are used for making fines. Ball mill is used for making fines. Powder. After crushing, grinding, and then also screening. Crushing, grinding, calcined clay, and screening. Screening into different fractions. Different fraction, that is either 1 to 3 millimeter or 0 to 1 millimeter. These fractions, different fractions are screened, and different fractions are kept in silos, from where it is taken for making the batch. So This is taken to the batch making. From here different fractions are taken for making batch. Then use pulverized plastic clay, pulverization of plastic clay. Of plastic clay. Plastic clay is obtained in the forms of lump, so it is needed to pulverize it to convert it in the powder form. Then pulverized plastic clay is added to the batch. Required quantity of plastic clay added, and we also need high alumina bearing materials, that is graded calcined bauxite. Calcined kyanite. Siliconite. Also named fused alumina. Etc. High alumina bearing materials. Generally needed for making high alumina bricks. But here also some amount of bauxite and kyanite is needed. So this is also charge required raw material from high alumina bearing materials also charge into the batch. Then it goes for mixing. Mixing. Mixing is done in counter current planetary mixer. Counter current planetary mixer. Mixing is done in counter current planetary mixer. Batch charge in the mixer, then it is dry mix for 2 to 3 minutes, and then binder is added, and finally mix for 10 to 15 minutes. Binder, molasses is used generally. Molasses is used as binder. Slurry of molasses. Molasses. Density is maintained around 1.3 to 1.5 gram per cc of molasses slurry. It is added as binder during mixing. Initially 2 to 3 minutes dry mix is done without binder, and then binder is added. Required amount of binder is added and mix further for 10 to 15 minutes. After mixing, pressing. Bricks are made in pressing. Pressing is done. There are various presses. Hydraulic press or friction screw press. Pressing is done in either friction screw press, friction screw press are of various capacities, either 80 ton or 100 ton or 150 ton or 200 ton. Depending on the size of the bricks they are used. Or hydraulic press for large shapes. Hydraulic press is used on 400 ton capacity for large shapes. After pressing, bricks are kept in, green bricks are kept in dryer for drying. The next step will be drying. Drying is done at 110 degrees Celsius plus minus 10 degrees Celsius. Minimum 24 hours. After drying, loaded in the kiln, that is firing. Generally, firing is done if the factory plant is a smaller scale. Firing may be done in DD kiln or shuttle kiln. Otherwise, either firing done either in shuttle kiln or DD kiln or chamber kiln or tunnel kiln. Shuttle kiln. Or chamber kiln. Or tunnel kiln. Chamber kiln and tunnel kiln are used for large scale production, large capacity plants, and for small plant, DD kiln or shuttle kilns are used. After firing, sorting is done. And good quality bricks are sent to the brickyard. From where samples are taken for inspection or testing and then supplied to the customer. And during sorting, some rejection are there. So rejected bricks are again circulated in production. Rejection bricks are again processed, crushed, ground and mixed to the batch. Part of calcined clay is replaced with rejected bricks for making grout. Sometimes fireclay bricks are also salvaged from plants, for example steel plants. In that case, you can totally replace calcined clay with the fire bricks grout. So you can replace calcined clay partly or totally with, if available, fireclay bricks. Used fireclay bricks, you can use it. So this is the flow chart for making Fireclay bricks and alumina bricks. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.